Hi, welcome. This is Chapter 6, First Section 1, Graphing Systems of Equations. Okay, content standards, you can pause this, take a look. I'm going to be moving rather quickly through this, so as opportunities exist, you may pause this, copy down what's on the screen, and then move forward. For this part, I would just like you to go through and read this. Okay, this is the then. We were graphing linear equations. Now we're going to be graphing two linear equations on the same coordinate plane. It's going to be called a linear system. We're going to be determining the number of solutions a system of linear equations has. We're going to be solving systems of linear equations by graphing. Okay, again, pause that so you can get enough time to write this down. Okay, new vocab. Okay, two equations such as y equals 2x minus 2 and the other equation, y equals negative 1x plus 1. They form a system of equations. So what we can do is we can graph both of these on the same coordinate plane. Okay, so first one here, y equals 2x minus 2. So from the origin, you're going to go down from here, go down to your negative 2, that's your y-intercept. Okay, negative 2. You're going to do your slope, negative 2 over 1, or sorry, positive 2 over 1. 2 over 1, 2 over 1, 2 over 1. Okay, that becomes your line. Draw the line that connects to those points. Okay, we can extend the line further if we need to. Depends on where the other graph is. Okay, for the other graph, positive 1 is your y-intercept. So starting at 1, slope is a negative 1 over 1, down 1 over 1, down 1 over 1. Okay, and that's the negative line going through those points. Okay, and then what becomes your solution is the point of intersection. Okay, that point there, which is 1, 0. So this becomes your solution. You can have one solution, you can have infinite solutions, and you can also have no solution. If the lines do not intersect, there is no possible solution. Okay, and we'll get into the rest of those examples as we move on. Okay, so but for right now, we are concerned with where that intersection point is. Okay, so from the origin over 1, up and down 0, so it's 1, 0. Alright, moving on. Again, pause this if you need to so that you can write down everything that I just put on there. You can also rewind it and listen to it again. Okay, if it has at least one solution, it is called consistent. Okay, that goes back to the vocab. If it has one solution, it is consistent. If it has exactly one solution, it is independent. So that's at least versus exactly one. There's a difference there. Okay, if it has infinite number of solutions, it is what we call dependent. That one was independent. Okay, and if it has no solution, it is labeled as inconsistent. Okay, graphically, here's what these look like. Okay, when they cross and have a solution, the terminology is consistent and independent. Consistent because it has at least one solution, and it's independent because it has exactly one. So it's at least and exactly. It works for both of those, so that's why we get consistent and independent. Okay, this next one here, when you graph the two lines, they actually lie on top of each other. So the only points of intersection is where is the entire line. So there's an infinite number of solutions, but they are specific. They are specifically on that line. So it is consistent because it has at least one solution, and it's dependent because it's an infinite number of them. Okay, and the third one over here, you have two lines that are parallel. They will never intersect. They'll never touch. They are labeled as inconsistent. There is no solution to that. Because the solutions to these linear systems is where that common point is, where that point of intersection or points of intersection. Okay, again, pause it if you need to, rewind it, watch it again. Moving on. Okay, use the graph to determine whether a system is consistent or inconsistent, and if it is independent or dependent. Okay, so you have your linear system, your two equations there. They are graphed. And you should hopefully already came to the conclusion that this is inconsistent. There is no point of intersection. Okay, B, use the graph to determine whether a system is consistent or inconsistent. Okay, it's going to be consistent. It has one point of intersection. And independent or dependent is going to be independent because it has the one point of intersection. Okay, remember back there, dependent was if it was an infinite number of solutions. Okay, so it is both it is both consistent and it is independent. Okay. Consistent and independent. That's what we just did. That was the solution for it. Okay, use the graph to determine whether the system is Okay, so pause this, take a minute for yourself to see if you can get this correct. When you are finished, hit play and check your answer. Okay, answer is A, consistent and independent. Okay, it was 2y plus 3x equals 6, okay, which was the line here. The other one was yx minus 1, which was here. They had the 1 point there that they were crossing, so it's consistent and independent. Okay, B, again, same thing. Take a look at this, do this on your own first, and then hit play and see if you get it correct. And you're doing the x plus 4 line, which is here, and you're doing the x minus 1 line, which is there. Hopefully hit pause, and now hit play. Okay, so that was inconsistent. Those lines are both parallel, they never touch. Okay, graph the systems of equations and determine whether a system has no solution, one solution, or infinitely many solutions. The system has one solution, name it. So don't just say that it has one solution, actually find if it does have a solution. So find that point of intersection. Okay, y equals 2x plus 3, and then you have 8x minus 4y equals negative 12. To be able to graph these, you want to be able to put them both into y equals mx plus b format. This one's already there. Bottom one, isolate the y. So let's move the 8x. Left with negative 4y, that canceled, equals negative 8x. We're going to put that in front. And it's not plus 12, it's minus 12. Okay, divide both sides by negative 4, negative 4, negative 4. You get y equals 2x plus 3. And if you notice, this is the exact same equation as that. So when you go to graph it, the lines are going to lie on top of each other. Okay, so the graphs coincide. There are infinitely many solutions of the systems of equations. Okay, and all the infinite number of solutions are all the points that lie on that line. Not the line I just drew because it doesn't, it went off, but you get the idea. Okay, B, graph the system of equations and determine whether the system has no solution, one solution, or infinitely many. The solution has, if it does have a solution, name it. Okay, so again, for both of these, you would isolate the y, so you get the equations in y equals mx plus b format, graph them, and check to see what they are. Looks like this first one, when you subtract the x and divide by a negative 2, you get y equals 1 half x minus 2. The bottom one, y equals, subtract the x, divide by a negative 2 as well, 1 half x plus 1. And if you notice, the slopes are the same, which means they're going to be parallel. The y-intercepts, though, are different, so they're not going to coincide. They're going to just be parallel lines. So this one has no solutions. They never will touch. Okay, and there's a graphical representation for you. Never intersect, they never touch, no solution. Okay, again, pause this, check your answers, and then hit play. Okay, one solution, and that solution is at 0, 3 when you go to graph, and that is your point of intersection. Okay, graph the system of equations, determine whether a solution has one solution, no solution, or infinitely many. Okay, so you can do the same thing, graph this. This is, if you can't see that, x plus 3y equals 4. The other one is 1/3 x plus y equals 0. Okay, those are going to be the ones that you're going to graph. Okay, when you graph that, you get parallel lines, so they have no solution. Okay, Narish rode 20 miles last week and plans to ride 35 miles per week. Diego rode 50 miles last week and plans to ride 25 per week. Predict the week in which they will both have ridden the same number of miles. So this is where we create the two linear equations, graph them. The point of the intersection is going to give us the solution to this. Okay, so the equation. Okay, so number of miles ridden equals number of miles per week times number of weeks since 1 plus number of ridden in 1 week. So if you can't read that, y equals 35x plus 20. The other one, y equals 25x plus 50. So this is, again, the rate at which they're writing and what they've already written. Okay, so that's creating your linear system. Okay, you go to graph these. Here's your point of intersection. So you make that bigger a little bit. Okay, if you follow that down, it's at the 3 going horizontally, and vertically the zoom didn't work so well, so I couldn't see that. But it's going from the 3 there, and looks like in the 125-ish. Let's see, yeah, 3,125. Okay. And if you wanted to check this, you would plug in 3 for x here. 3, plug that in. Plug in 125 for your y, and check to see if the left equals the right. If it does work for both, then that is the intersection. Because it is a little bit hard to graph out and get the exact point. So once you believe you found the right point, plug it in, check to make sure it works. Okay, there's a check for it. Alright, Alex and Amber both saving money for a summer vacation. Alex has already saved 100, plans to save 25 per week until the trip. Amber has 75 and plans to save 30 per week. Okay, so you have a rate of change, how much you're making per week, you have how much you already have. Graph both of those. The graph looks like this. Point of intersection is there. Follow it down, 5, and between 200 and 250 looks like 225. So in how many weeks will Amber have the exact same amount of money? Number of weeks there is 5. 5 weeks. Okay, there's your homework. Please get started. I believe this is 8 problems for you to do. Please do not just sit there and talk with your friends. Please get started, ask questions, figure out how to do this before you leave. Thank you, and have a great weekend.